In this lesson we're going to look at finding the area of a triangle. Now up until now we've only had one formula to find the area of a triangle, and that's when we've been given the base and the height. So in this example we can see that the base is 15 and the height, or perpendicular height, that means it's at right angles to the base, is 7. So a half of 15 times 7 over here gives us 52.5 square centimetres. Now there is another formula called Heron's formula which can be used to find the area of any triangle, but you need to know all three sides. Now Heron's formula involves finding an item called the semi-perimeter. We use S for the semi-perimeter. So the semi-perimeter means half the perimeter of the triangle. The perimeter of a triangle is the three sides added together, so the semi-perimeter we would need to halve that. You'll also notice in Heron's formula S appears here, here and here as well, and the sides A, B and C also appear. So let's have a look at an example. Over here we have a triangle with three sides, 4, 6 and 8. First I find the semi-perimeter by adding 8, 4 and 6 together. Dividing by 2 I get 9. Now in Heron's formula I replace S with 9 and I multiply it with S minus A, so 9 minus 8, S minus side B, 9 minus 4, and S minus side C, 9 minus 6. It doesn't matter which sides I call A, B and C, as long as I represent the sides of 8, 4 and 6 here, here and here. So really we're taking this semi-perimeter S and then we're taking its difference to each side. How different is 9 to 8? It's a difference of 1. How different is the semi-perimeter 9 to side 4? Side length 4? It's 5 different. How different is the semi-perimeter to this side over here, which is 6? Well, it's 3 different. So it's the semi-perimeter multiplied by its difference from each side, and that gives me 135 under the square root sign. Don't forget to take the square root, and we get 11.62 square centimetres. So Heron's formula. Another way we can find the area of a triangle is if we don't know all three sides, we can get away with knowing just two sides and the included angle. In this formula we use area of a triangle, which is half AB sine C. So in this case we have two sides 8 and 12 and we need the included angle. So half of AB sine C gives us a half of 8 by 12 by sine 30, and we get 24 square centimetres. Alright, so why the crocodile? Well, we did use that for the cos rule when we wanted to find a side or angle, and the situation we could use the cos rule was a situation like this where we knew two sides and the included angle. Well, we can also imagine if we had crocodiles in the area, we can use the crocodile jaws and the angle between to find the area of the triangle. So that's just something useful to remember. Let's move on though and look at some application questions. In this case we want to find the area of the shaded segment in the circle that's shown. Now a segment looks a bit like the segment of, say, an orange or a mandarin. So there we go, we've got a radius of 5 here. That will be 5 as well. What we can do is to find the shaded area, we could find the area of this sector, so that's a fraction of a circle. Then we could find the area of the triangle, this white triangle, and by subtraction we'd be able to find the area of the sector. Sorry, the area of the segment. Let's start with the sector. It's a fraction of a circle, so it's our angle out of 360 times pi r squared. Our angle over here is 110 degrees, So 110 out of 360 times pi times 5 squared gives us 24 kilometres squared. To find the area of our triangle, well, which triangle formula do we use? Do we know the base and height? Nope. Do we know all three sides? Nope. Do we know two sides and the included angle, just like the jaws of a crocodile? Is there a crocodile in the area? 5, yes there is, 5 and 110. So we can imagine a crocodile's jaws there. So we'll use a half AB sine C. A half of 5 by sine of 110 gives us 11.75 square kilometres. Now that we know the area of the triangle, we can find the area of the segment by subtracting our 11.75 from our 24, and we get 12.25.